My name is John LeVar, and I'm a volunteer at Pompey's Pillar with the Bureau of Land Management that runs the Pompey's Pillar. And I'm here to talk today about mapping with William Clark and the maps that he made on the Lewis and Clark expedition. This first map here with the title on it is deliberately picked because this is Billings, Montana, up in here. That's where I give most of my talks. And this is Colson Park right down in here. So you can relate to this. This is Clark's Fork of the Yellowstone there. So you can have a relationship right there with his map that he drew in the field. This story really starts in 1492 when Columbus sailed the ocean blue. He was looking for a route around the earth to get to China and Japan and India. And when he landed, he was going this way. He didn't know that this stuff was in the way. He came and landed in here. He thought he was over here. And he made that trip 3 times, and he never did know that he had actually discovered a whole new continent. So, but this is a continuation of that story because people continued to look for a route across the continent. And the first white man who made the trip across was Alexander Mackenzie. He was a Scotchman. He did this up in Canada. He's a pretty good looking guy, actually. This is his map. This is 300 years after Columbus. They're still looking for a water route across here. And he traveled from eastern Canada here across to Lake Athabasca. And the first year he tried this, he got on the wrong river and he went up to the Arctic Ocean. Can you imagine making that kind of mistake? You think you're going to the Pacific and you go to the Arctic instead. And but they did name the river that he was on, they named it the Mackenzie River. And for those of you who are local here, you know that name, Mackenzie River Pizza. Mackenzie River Pizza. So whenever you kids go to Mackenzie River Pizza, remember that it's named after the first white man to cross the North American continent. 2 years after he made his big mistake, he came out this way and got out to the coast out here and put his name on a rock. And then he wrote a book. And the book was published. It was a journal of his trip. And it was published, and in 1802, do I have a, no. In 1802, Thomas Jefferson got a copy of the book. And in 1803, he's got Meriwether Lewis preparing for the trip out here. And there's many historians today that believe that that book was the catalyst because at the end of the book, Mackenzie recommended that the British government build forts along this side of the continent so that the fur traders could bring their furs to those forts and go straight over to China without having to go around Africa and across the Atlantic Ocean. And because a lot of the furs were sold, the finest furs were sold in China. I'm going to give you an idea of the contrast. Mackenzie traveled up here in Canada, and Lewis and Clark traveled down here in the United States. So Lewis and Clark were farther south, and we're very certain that Lewis had read Mackenzie's book. And now a little something about the Louisiana Purchase. This is another myth that I'd like to dispel. When I was a kid, I was taught that the Louisiana Purchase was purchased, and then Jefferson sent Lewis and Clark out to explore. And that really isn't what happened at all. If you look at the timeline for it, there's 2 very separate events occurring, and they happen to mesh very nicely at the end. One of the events was that the Spanish thought they owned the Louisiana territory. They did not. The King of Spain had given that back to France. But the people down here in New Orleans, the Spanish down here in New Orleans, that were running all this, and the Spanish that were up here in St. Louis, they thought that they still, that Spain still owned the Louisiana Louisiana Territory. And the farmers that were working up here in the Illinois country were trying to ship their goods down the Ohio River, down to New Orleans, and then ship it around the coast up into the colonies here. Or they weren't colonies anymore, they were states. And the Spanish in New Orleans were denying them the right to store their goods in New Orleans. And the farmers wanted Jefferson to do something about it. In fact, they wanted him to go to war. And Jefferson refused to go to war, but he did send a delegation over to France, because he had heard rumors that France actually owned this territory, and he wanted to purchase the city of New Orleans and part of this stretch of land here, this West Florida. That's all. That's all. At the same time, he reads Mackenzie's book, and he says to Meriwether Lewis, "Would you like to go out and cross this thing? We want you to go across." And so Lewis was planning the trip simultaneously with the people over in France that were trying to buy the territory. Now, when Napoleon wouldn't even talk with the delegation from the United States until the army that he had sent down here into the Caribbean just about all died of malaria. And he realized that he wasn't going to be able to come up here and occupy this or do anything with it. So he decided to get as much money as he could out of the United States to sell it to them. And I think it was $15 million that he got for it. And the irony is that he wanted the money so he could fight the British, and the Americans borrowed the money from a British bank to pay him for the territory. So he's buying more goods to fight the very people that he borrowed the money from. Now, and also Lewis had a passport from Britain and from France to move into this territory. They tried to get a passport from Spain, and Spain wouldn't give him a passport. So the Spanish later on actually sent some delegations up here to try to stop the Lewis and Clark trip. They failed, but it's all part of this story. So the two events, in fact, the day after Lewis left Washington, D.C. to come out here, the newspaper ran the article that we had bought the Louisiana Purchase. So there were two events that happened separately, or they were separate events, but they merged together. And when Lewis and Clark stepped across the Mississippi, they were on American territory. They didn't intend that at all when they planned the trip. This is William Clark. He's the one who made most of the maps. And this is an overview of the Lewis and Clark trip from St. Louis up to the Mandan villages in 1804, 1805. They come out here to Fort Clatsop. 1806 they come back, they split up. Lewis goes up this way, and Clark comes into the Yellowstone area. And we're going to talk a lot about the Yellowstone area because that's where we live, and that's the maps that we're going to take a look at. Jefferson wrote pages of instructions to Lewis, and this is an extract from those instructions. The object of your mission is to explore the Missouri River and such principal streams of it as by its course and communication with the waters of the Pacific Ocean, whether the Columbia, Oregon, Colorado, or any other river may offer the most direct and practicable water communication across the continent for the purposes of commerce. This is important right here, for the purposes of commerce. They said that this was a scientific expedition, that they wanted to find out about the land and the animals and the plants and all that. That's what they told England and France and Spain. What he said to his own purpose, his own man, Jefferson wrote, "We want you to be out here for the purposes of commerce." So it's a whole different attitude toward the trip. And when you read the journals, you'll see that a lot of the stuff they wrote in the journals has to do with, can somebody live here? Can they build a house here? Can they survive here? Can we have commerce here? He goes on saying, beginning at the mouth of the Missouri, you'll take observations of latitude and longitude at all remarkable points on the river. And we will talk at length about latitude and longitude. Your observations are to be taken with great pains and accuracy, to be entered distinctly and intelligibly for others as well as yourself. That's like a teacher saying, write it so I can read it, kids. It's no good if I can't read it. To comprehend all the elements necessary with the aid of the usual tables, to fix the latitude and longitude of the places at which they were taken, and are to be rendered to the War Office for the purpose of having the calculations made concurrently by proper persons within the United States. Now, if I'm doing kids, talking with kids, I start asking them, what's the War Office? And of course, the War Office is the Department of Defense. That's what we call it today. And I ask them, why would they be giving this money, this information back to the Department of Defense? And the answer to that I try to draw out of them is that this was a military expedition. Military expedition reports back to the War Office. And so that's what this is about. By the way, that isn't what happened, but that's what was supposed to happen. Now, what are latitude and longitude? And latitude are the lines that go around the Earth this way. And of course, you can ask kids this question and see if they know it. You don't have to supply the information first. And longitude go from North Pole to South Pole. So the latitude slices the Earth, and longitude sections it like an orange. And you put those two together, and you get this. And it looks like a piece of graph paper, and it works exactly the same way. The latitude and longitude are imaginary lines, man-made lines on the face of the Earth, going in the, as is shown here. And this works just like a piece of graph paper. On a piece of graph paper, you have an x-coordinate and a y-coordinate, and if you put those two things together, you find an exact point on that piece of graph paper. On the face of the Earth, if you know the latitude and the longitude, two pieces of information, put them together, you have an exact point on the face of the Earth. So it works exactly the same way, and that's why you learn this stuff in your math class. Now, how do they find this stuff? They use the sextant. And this is a sextant, and I'll pass this around so you get a chance to see it. Okay, now, this is a sextant. And as new technology, it was invented in 1731 simultaneously by John Hadley in England and Thomas Godfrey in Philadelphia. People always ask that question, and I can never remember it, so I've got it in here. Here's how the sextant works. When I look through this barrel, I see this round thing here. And it's a split mirror, if you can see it, and you probably can't in this, but it's a split mirror. And the left side is clear, and the right side is reflected. So that I can look straight through one side, and I'm reflected on the other side, and reflects up into this mirror here. So this mirror is reflecting up into the sky, and it's attached to this arm right here, and this arm rotates. And so I can measure the angle between whatever I'm looking at through the clear side and what I'm seeing up in the sky, and the angle is measured right down here. And this has a vernier caliper on it that we used to learn how to use in school. Kids don't know anything about anymore. It has a magnifying glass to help see it. These are sun filters so that you can look at the sun. Your mother told you to never look at the sun, and this will blind you if you look at the sun with it. So to go over this again, the sight picture you see on the clear side has the sky and the land. And what's this line called right here? You're right, it's called the horizon line. Okay, so you find the horizon line, and then on the reflective side you find the sun, and you bring the sun down so that it sits on the horizon line extended. Okay, so if you extend the horizon line out, and the sun sits on it, that's at noon, right at 12 o'clock noon, and when you get that picture, you read the angle down here, and then you go into the tables, into the proper tables, as Jefferson said, and you find the day of the year, you find the angle, and it will tell you your latitude. Longitude is quite a bit more complex than that. And I would pass this around at this time. Okay, that's right. Sun is higher in the sky in the summer. Shoot the sun at noon. Read the angle above the horizon. You must know the day of the year. Consult the tables. How do you know the local time? Now, we live in time zones. But back then, each village, each town, had its own sextant, they called it, and he would shoot the sun at noon, and each town had its own clock and its own time. And it was different as you crossed the country, or Montana, by a few minutes. As you traveled, each town would have a slightly different time. And that's the time that we want on the sextant. You know, that's what we're looking for. But how do we know the time? We use the sextant to shoot the sun in the morning. Okay, and at the same time, we use our watch as a stopwatch. So okay, we're going to start counting from that moment that we got the sun in the morning, maybe at 10 o'clock, say. And then we use the clock as a stopwatch, which I just said, and then you wait until the sun gets to exactly the same elevation in the afternoon. So it's gone past noon and over, the same amount that it had been in the morning. And now you take a look at your watch, check the time elapsed, divided by 2, and that's the time at the present time when you got the second shot. Then you can wait till the next day if you don't move from that location, and if you know that your watch is accurate, you'll know when noon is. And that's when you want to shoot for your latitude. Set the clock. Okay. All right. But the horizon is not consistent. Think about it. You got hills, you got trees in the way. Horizon is not, the only place it's consistent is on the ocean. So on land, you must use something called an artificial horizon. And it's usually a pan of water or mercury. Now you know that water, any liquid, you let it sit still, is level. So that's what they use. And then to stop the wind from blowing on it, they have it protected by glass. There's glass, and a lot of the guys carried mercury with them. And it's poisonous and all that sort of thing. They carried mercury with them, and they use that because in winter, the mercury doesn't freeze, but the water does. So you need the mercury for winter observations. And when you have the artificial horizon and you have the water there, when you look through the clear side into the water, and you look at the sun with the other piece, the reflective side, and that just happens to be twice the angle that you'd have if you looked at the horizon. So when you see you line up two suns next to each other, you divide the angle by 2, and you get the angle from the horizon up to the sun. And a sextant doesn't swing far enough to make that measurement in summer, especially up here. And so they have to use something called a quadrant to do that. And Lewis and Clark did have a quadrant with them. Now, longitude. How do you find longitude? The way to find longitude is you know the local time. Remember the exact local time, not the time zone, but the exact local time. And you know the time in Greenwich, England. Okay? When you know those two times, you subtract them. And since the Earth rotates, well, you multiply by 15. And the reason you multiply by 15 is because the Earth rotates 24 hours in 360 degrees. So you divide 360 degrees by 24, is 15. So that's why you multiply the hours by 15. And it works very nicely. Okay, why multiply by 15, I just told you. Okay. All right. The Earth rotates 15 degrees each hour. Okay, now, I need to get my compass out. Now, the problem with that I just talked about is how do we studied how to find the time, the local time, But how do you find the time in Greenwich, England? And that's the problem. That's the problem. And today it's easy to do. You know, you just can get on the telephone and check if you want. But then they couldn't, and there was a big contest to design a clock that would hold the time. They would set it at Greenwich, England, and then put it on board their ship and carry it with them, and then they'd shoot the sun, and so they could make these calculations. There's another way to do it. You can look at the moons of Jupiter, and somebody's figured out the differences in those moons, and with a whole bunch of calculations, you can figure out what your longitude is. But it takes about an hour's worth of mathematics to do that, and I'd like to see anybody who can do an hour's worth of mathematics without making a mistake. So it's not easy to do. So they used it, but only a few times, maybe 20 sometimes. They take these evaluations with a sextant. What they used was a compass, and this is a replica of Clark's compass. If you look at it, you'll notice that, and this happens to be a photograph of Clark's actual compass. It's in a museum in Philadelphia. It starts at 0 here, goes to 90, and back to 0 here, and then back to 90. So you have to read this different from a modern compass. Modern compass goes 180 down here and then 270 here. You have to use it differently, and you say, I'm looking north, so many degrees east or west, or I'm looking south, so many degrees east or west. If you press this little button down, it raises the needle, activates this lever, it raises the needle, and that secures the compass so that it doesn't get damaged when it's in your pocket. And I'll pass this around as well so you can take a look at it. And Clark used the compass more than he used the sextant. He used the compass all the time, and it's called, what he did is called dead reckoning. Dead reckoning. And to give an overview of his trip, he started down in St. Louis, went up to Fort Mandan for the winter, then they came down here, out to the west coast, and then they came back, split up, and Clark traveled down the Yellowstone River. And there were some early explorers of the Missouri, and Lewis and Clark used their information. One of the fellows was called Menard. Menard lived with the Mandan Indians for quite a number of years, and he died just a few months before Lewis and Clark got there. So they never met Menard, but all the other people that traveled up the Missouri River to the Mandan villages did. And one of the fellows that traveled to the Mandan villages was David Thompson. He was with the fur trade in Canada, an excellent map maker, and he came down and had mapped the Mandan villages before Lewis and Clark ever got there. Two guys, James McKay and John Evans, were businessmen from St. Louis, and McKay sent Evans up the Missouri to the Mandan villages, and Evans was looking for the Welsh Indians. There was this big myth about the Welsh Indians, and he was looking for them. But Evans talked with Menard and got some information and made some maps of the upper Missouri that Lewis and Clark used. In fact, this is David Thompson's map. Here are the Mandan villages. Notice he's got a river here. He's got the Missouri coming in here. He's got another river coming in here. This is probably the Yellowstone right here. Okay. This is the Knife River. This is probably the Yellowstone. And what does he call it? I can't read it. Looks like this is the Lesser Missouri. The Lesser Missouri. That's David Thompson's map. Now, also Captain Cook had gone along the west coast, and he had mapped the west coast of the United States. So Lewis and Clark knew the latitude and longitude on the west coast. They knew the latitude and longitude from David Thompson to the Mandan villages, and they knew the latitude and longitude at the mouth of the Missouri River before they ever started. And then we have to look at some of the theories about the continental theories. And John Logan Allen is a historian who has written this wonderful book called Lewis and Clark and the Image of American Northwest. And it's all about mapping and what they thought about what the continent was. And one of the theories was the symmetry of the continent. You have to realize these people were very religious, and they thought that America was God-given, and that it was, so it must be symmetrical. And if you look at the map, you can kind of understand why. You've got the Appalachian Mountains out here, and you have the Cascade Mountains out here. Okay? You have the Mississippi River, they thought came right down the middle. You've got the Ohio River coming in here. You've got the Missouri River coming in here. Looks like you ought to be able to fold this thing over on itself, and it would be symmetrical. They didn't know about this, the Rocky Mountains.
Yeah. Okay,
that's the piece they didn't know about. So they had this idea that the continent was symmetrical, and that was a theory that they used. And then they had another theory that there was a high point of land that was the source of all rivers. They thought that it was kind of like a railroad terminal. You could get up on this high point of land and switch from one river to the other and go wherever you wanted on the continent in the West. And it was a nice theory, and it just wasn't true. And they said that there was an intermingling of all these river sources on this high point. And they also thought there was a single range of mountains for the Rocky Mountains. Now, the Nicholas King map we'll talk about was based on an Aaron Arrowsmith map. Aaron Arrowsmith was probably the premier map maker in Europe at that time. And King also used David Thompson and Captain George Vancouver for the West Coast. And Nicholas King was asked to make a map of the best map they could of the area that Lewis and Clark were going to go explore. And so this is the map that he came up with. This is the Nicholas King map of 1803. And you notice that this is Lake Michigan, this is the Mississippi River, this is where St. Louis is, this is the Missouri. Notice it turns into a dotted line, comes up to the Mandan villages that had been mapped by David Thompson, and then it comes out here, and he has this lesser Missouri here. And here's the Missouri River. Here's the single range of mountains. And if you notice down in here, he has these rivers all meeting together. Okay? This was the high point of land. And zoom in on this a little bit so you can see it a little bit better. This is the Mandan villages. Here's the lesser Missouri. They didn't know the name of the Yellowstone. They didn't call it the Yellowstone. And here's the source of the Rio Norte, okay? And of course they say down here very honestly, this is conjectural. In other words, they really don't know what's there. They really don't know what's there. But here's the string of the Rocky Mountains, one chain of the Rocky Mountains. And here's the high point of land, where you see the various rivers coming in. Okay. Now, and here's the one mountain range. Now, when they got to St. Louis, they met Evans. McKay, or they met McKay. Evans had died, but they met McKay. And McKay gave them a copy of Evans' maps. So these maps are far more accurate than the ones that Nicholas King used. And this is the lower Missouri. You can see there's all kinds of names on it, and up here we see that it goes off the map. We think this is William Clark's handwriting. They took it off the map and put the Yellowstone River in. But this is the map that they got from McKay Evans. And there's the map up there. In fact, it is written upside down, Yellowstone River. Yellowstone River. So they found the name of the river, anyway, at that point. And this is Evans' Upper Missouri map. And you can see that he has several mountain ranges in here, so that myth is already dispelled when they're in the Missouri. This is the Yellowstone, and they call it the River Yellow Rock on this map. River Yellow Rock. and here's the Missouri, and it goes through one mountain range, around one, and then heads south. And that's really what happens. But they didn't want to believe that. They didn't want to believe that at all. When they get up to the Mandan villages now, they're just like any tourist. They're asking people along the way, you know, where's a good place to eat, and what does the terrain look like out there in front of us. And this is Sheheke, and that's his wife. They went back to Washington, D.C. with Lewis and Clark at the end of the expedition. That's where these portraits come from. And Sheheke helped Clark make a map of the Yellowstone. And this is the map. Here's the Missouri River. There's the Yellowstone, comes down and curves. That's one map that he helped me make. This map really shows the way the Yellowstone actually goes, but this is the map that Clark used. Here's the Missouri, here's the Yellowstone. Notice all the rivers come in from the south. That's the way it happens. He's got them labeled with Indian names. You can get the translation of those names, or the names that we use today, the tongue, the powder, the bighorn, and so on. What's really interesting about this map, in my mind, is this particular bump right here. It doesn't exist, or not really. Billings is right here. Pompey's Pillar is right here. There is, if you travel on I-94 from Billings to Pompey's Pillar, you'll notice the river tends to drift away from the road and then come back. That's what this is. But this is a huge exaggeration of that. And what's interesting to me is how far this particular anomaly carried on in maps into the future. And we'll talk about that a little bit later. When Clark got up to the Mandan villages, he made this map of the territory. It's much, it's filled in from the Nicholas King map. He's got all this information right here. This has all been explored. And now out here he's got the Missouri and he's got the Yellowstone. You see there's what I call Sheheke's Bump right there. And he's got it in this map. And here he's got the Missouri going through one mountain range, two mountain range, three mountain range. Has to come out all the way to the last mountain range, and then he's going to get on a river and come out the other in the Pacific. So he doesn't believe the Evans map, that the river does not go through all the mountain ranges. This is the blow up of that area, the same map. You can see he's got the highland, the high point of land here, and over here he also has a high point of land. And what's ironic about this high point of land where all the rivers have their origin, if you know where that is on the map, it's the Great Basin. It's below sea level. So it's not the high point at all, it's just exactly the opposite. That's the high point of land I'm talking about right in here. So that's the Great Basin. Now, how did Clark do this? It's called dead reckoning, and he used his compass and he estimated distances. And as he traveled, he said, I'm traveling south 1 mile to a lower point of an island on the starboard or the right side. When he gets there, the river bends. And now he's going a new direction. And so he says, okay, now I'm going north 62 degrees east 3 miles to a point on the left bluff, the larboard bluff, past the lower point of an island. And when he gets there, the river bends again. He said, now I'm going east 3 miles to Pompey's Tower. And he describes it. And this is just right before he gets to Pompey's Pillar. And the significance of this is that at every bend in the river, he has to take a reading. And that's what's called dead reckoning. And he has done this from the mouth of the Missouri all the way out to the mouth of the Columbia River. And now he's coming home on the Yellowstone, and he's making these kinds of readings, and that's how he made his maps, or from these readings. These are the readings that he took on the day he passed by Pompey's Pillar. The stuff I showed you is down in here, and he's writing this with a quill pen. And that night he writes this, and from here to here he talks about the pillar. So you see, he's writing an awful lot of stuff. And then he makes a map. This is Clark's map of Pompey's Pillar. Right here he calls it Pompey's Tower. And there's features here that if we're out of the pillar, I could point out to you and show you that they're still there. That map is still a good map of the area, and it's pretty phenomenal. He took all those maps. Oh, by the way, this is Maximilian's map of Pompey's Pillar. Right here is the pillar. And Maximilian came out in the 1830s, Prince Maximilian, and I think Reuben Clark, relation to William Clark, had redrawn all these maps, and they gave them to Maximilian. And so Maximilian took them back to Germany, so we have this other set of maps. And there's information on these maps that is accurate but not available on Clark's maps, which is kind of fascinating, which means that, to me at least, it means that Clark had another set of maps that we don't have. And again, this is Clark's map of Pompey's Pillar in the direction that it's actually going. This is the north. And notice here he's got the crick in, he made a mistake, crossed it out, moved it over. This little ridge right in here is very visible from the pillar. You can see it, so that it's really pretty accurate. That's the pillar today. Notice that this pillar here, if you look out here, here's where the river curves in, comes back out, and goes back in, and there's the island out there. And then we're going to look at this, I think, next. Let's see what's the next one here. Oh, well, let's go back one. You see this channel right here, and then it continues over to here. If you look at, that's on Clark's map, and then if we look at today on Google Earth, there's that channel. So you see an awful lot of the stuff is still here. It's pretty amazing, really. This is a photo of Pompey's Pillar taken in the winter when aren't any trees, or excuse me, aren't any leaves on the trees. So from the river, the pillar is not very prominent. But in 1873, when these photographs were taken from across, you can see that the pillar was very prominent because there weren't any trees here. So the river has changed some, but not a whole lot. And by the way, this particular photograph, you probably won't see it in a magazine or a book anywhere because the plate is damaged down in here. So a friend of mine got this from the Smithsonian. You're not going to see this map. This one you'll see. This is the one that's used the most. First photograph of Pompey's Pillar. This is a photo from the top. Let's see what the next one is. Okay, go back. This is from the top of the pillar looking west. Notice this cliff that comes out here, and there's a piece of rock here that you can see. If I go to the next slide, this was photographed in 1910. Over here is that cliff. And look at the river, way out here, way back. Okay, so that the river has changed a little bit over the time. If you want to see how complicated Clark's notes are, this is his field map, one of them, and he's got notes on here, stuff crossed out. It's a piece of work. I mean, he's not just drawing this stuff from scratch. And I like kids to see this because a lot of kids think that their first product should be the final product, and you have to understand that you've got working copies that you redo. This is the Clark map of 1814. This is the final map that he made, and here's the Yellowstone, and down here is Cheheke, so we know that he used that Indian information all the way to the end of his map. And this is that blow up of that area. This particular feature, by the way, I found a new book. It's not new, but I found a book that's new to me. And it's the maps of the American West. And this feature stays in the maps. And you remember, they came by here in 1806. And it stays in the maps until the 1870s. because people keep copying it into their maps. And in the 1870s, then we have the Northern Pacific Railroad coming out with real surveyors, real surveying equipment, and that's when this Shinneco's bump goes away. Okay, Clark's accuracy. There was a fellow by the name of Martin Pomp who took all of Clark's maps and put them on geodetic survey maps. And this is at the very end of this is out in the Pacific Ocean. And this piece right here, tiny print, he writes, I'll blow that up so we can read it. Cartographer's note. The total distance of Clark's traverse from the Mississippi, or the Missouri-Mississippi confluence to the Columbia's mouth is 4,013 miles. He reports the sum is 4,162 miles, a discrepancy probably due to attempting later corrections. Actual measured miles on modern USGS maps total 2,951 miles. Clark was 1,000 miles off. And even at Pompey's Pillar, the distance from the bend in the river to the pillar, he said was 3 miles, it's only 2. But the magic was, of his success, was that he knew the latitude and longitude at the mouth of the Missouri and at the mouth of the Columbia, and he made it fit. And he's only like 30 miles off. Well, of course he's only 30 miles off, because he's going by latitude and longitude, where he started, where he finished. And Plumond said that error can be due to the expansion or contraction of the paper that he wrote it on. So he didn't make any mistakes. He overestimated his distances, and then, as any good engineer does when it doesn't fit, you just kind of make it fit. Okay? You just kind of make it fit. I showed you that Johnny Logan Allen earlier, that book about the West. This comes out of his book, and he's made a map here. The dark map is Clark's map. The light map is a modern day map. Superimposed them in his book, and you can see that they're very close together. The Clark's map was really very accurate. This is the final map that Lewis and Clark made with their trip marked on the map. And this is Pompey's Pillar today, and I thank you.